Assalamu alaikum. Today the new topic is reduction formulas. It is used for solving any differential equation or integral equation. So we can now derive reduction formulas for integration of trigonometric functions. So the first reduction formula is that integral of sine power n of x. We will derive reduction formula for this function in this video. So integral of sine of power n of x dx is equal to sine of, we can write sine of n of x is equal to sine power n minus 1 of x with sine of x, because base is same, power will be 8, so it is equal to sine of x, sine power n of x. So I can write it is integral of sine of n power n minus 1 of x with sine of x with respect to x. This is the function which is equal to sine power n of x. So sine power n minus 1 of x and sine of x with respect to x. This is two functions which is sine of x and sine power n minus 1 of x. So these two functions are in product. So we can now apply the integration by parts rules on these two functions. So the first function is sine power n of x, n minus 1 of x and sine of x. This is the second function. So apply integration by parts rule on these two functions. So integration by parts is equal to first function integral of second function minus whole integral of derivative of first function and integral of second function with respect to x. So first function sine of n minus 1 of x, first function integral of second function, integral of sine of x is equal to minus cos of x. So first function integral of second function minus whole integral of derivative of first function. So derivative of n sine power n minus 1 of x is equal to n minus 1 sine of, it will be decreased by 1. So sine of n the derivative, so it is n minus 2 of x, and generalized power rule of differentiation, we will again take derivative of sine of power n of x without n minus 1. So the derivative of sine of x is equal to cos of x. So first function integral of second function minus whole integral of derivative of first function, which is equal to this whole function, and integral of second function. So integral of sine of x is equal to minus cos of x with respect to x. So we can now proceed these equations. So sine of n minus 1 of x with the minus cos of x minus whole integral of this is equal to n minus 1, and minus, we can multiply this minus to this minus, it is plus, so it is equal to n minus 1 sine of n minus 2 cos x multiply with cos x, which is cos square x, and cos square x is equal to 1 minus sine square x. So we can substitute the value of cos square x is 1, which is 1 minus sine square x. So it is equal to 1 minus sine square of x with respect to x. Now we will proceed it again. So it is equal to minus cos of x with sine of n minus 1 of x plus n minus 1 is a constant, so it will be out of this function. So it is equal to sine, so multiply sine of sine power n minus 2 of x to this function. So it is equal to sine of n minus 2 of x plus and minus with this minus, sorry, it will be again multiplied with this function. So it is equal to multiply these two functions, it is equal to sine of n minus 2 and minus, it will be taking in this way, minus sine of n of x with respect to x. So it is equal to minus cos of x sine power n minus 1 of x plus, now multiply n minus 1 to these two terms, it will be equal to n minus 1 integral of sine power n minus 2 of x dx minus n minus 1 integral of sine power n of x dx. This is the functions. So now multiply, we have to multiply these two functions, which is equal to minus cos of x sine of n minus 1 of x, and it is equal to plus n minus 1 sine of n minus 2 of x with respect to x. Now multiply minus to these two terms and multiply integral of sine power n of x, which is equal to minus n integral of sine of n of x plus integral of minus with this minus plus, which is equal to integral of sine of x with respect to x. So this side is equal to integral of sine of n of x, which is cancelled out with this, and this side is left with 0. So 0 is equal to minus cos of x sine of n minus 1 of x plus n minus 1 integral of sine of n minus 2 of x dx, and shift this term to this side, so it will be changed to plus. So n integral of sine of n of x dx is equal to minus cos of x into sine of n minus 1 of x plus n minus 1 into integral of sine of n minus 2 of x with respect to x. Now dividing n on both sides of this function, so integral of sine of n of x dx is equal to minus cos of x sine of n minus 1 of x divided by n plus n minus 1 divided by n integral of sine of n minus 2 of x dx. So now this is the reduction formula for sine of x, which is equal to sine of integral of sine of n of x. So if we denote integral of sine of n of x with in, so it will be equal to in is equal to minus cos of x divided by n sine of n minus 1 of x, n minus 1 of x plus n minus 1 divided by n, and sine of n minus 2 is denoted by sine of I of n minus 2. So this is the reduction formulas. This is overall the reduction formula. So integral of sine of n of x with respect to x is equal to minus cos of x sine of power n minus 1 of x divided by n plus n minus 1 divided by n integral of sine of power n minus 2 of x with respect to x. So thanks for watching the video.